Okay guys, welcome back. This is going to be day 2 of Unit 11. We're going to continue with graphing, and we're going to be sketching these graphs without the use of our calculator. Now obviously you guys have access to that, so you can graph it on your calculator just to double check. But I'm going to go through the process of how to do this without a calculator. So first, when we're given a polynomial, one of the things that I like to do is I like to multiply it out so I'd get an idea of what that first term would be. So in this case it would be x squared times x, or an x cubed. I don't really care what the middle terms are, but I am concerned about the last term. So if I were to multiply these out, that would give me a negative 48. So what does this tell me? Number one, it tells me that this is going to be a positive odd degree because it's a cubic and it's positive. And this term at the end gives me my y-intercept. My y-intercept is found by setting all the x values equal to 0. So if you set all the x's equal to 0, we're left with a negative 48. Alright, so what does that tell me about my tails? Remember, a positive odd has a general upward flow. So my tails are going to look like that. They're going to be in opposite directions and has a general upward flow as we go left to right. What I need to do now is I need to get my roots. Well, those are found by factoring the original expression and setting all those equal to 0. So what does that give me? It gives me a plus or minus 4, and it gives me a negative 3. Okay, so that's where it's going to cross the x-axis. So sketching that in quickly, it's going to cross at negative 4, negative 3, and positive 4. I know the y-intercept is negative 48. Well, I'm not going to draw that to scale. I'm just going to put a mark down here and call that negative 48, but I know the graph has to go through there. Now, if you take a look at your tails, what has to happen is the graph has to, as x approaches negative infinity, y is going to approach negative infinity. As x approaches positive infinity, y is going to approach positive infinity. So now I need to sketch something that will kind of connect those tails and go through all of those intercepts. So my graph's going to look like this. Again, this is just a very rough sketch. But all the key points are there. All of your roots and the y-intercept and the end behavior. So it's really that simple. What I'd like you to do now, just to verify, is why don't you put that into y1 on your calculator, take a look at the graph, and just compare it with what we just sketched. Okay, next one. A little bit more interesting here. So if I were to do the same thing, first term, x to the 4th times x squared, x to the 6th. Okay, so it's going to be a positive even. And I don't care what the middle stuff is. When you go to multiply those, that's going to give me negative 16x to the 4th. Well, remember what I said about the y-intercept. All right, I'm going to talk about that first. The y-intercept is what you get when you set all the x's equal to 0. Well, if you set all the x's equal to 0 and multiply that out, guess what? Y equals 0. Now, what might be easier here is to get your roots. Set each one of those equal to 0. X to the 4th equals 0. Well, guess what? X equals 0. X squared minus 16 equals 0. You can factor it. You can move the 16 over and take the square root. Just don't forget your plus or minus. So now, here's something that you should be aware of. Anytime 0 is a root, so x equals 0, guess what? That's also the y-intercept, because it can't go through another value on the y-axis, otherwise then obviously it would fail the vertical line test. So what we have here is we've got roots at 0 and plus or minus 4. It's a positive even. So that means my tails look like that. Well, let's see what's going to happen here. Got a root at negative 4. I've got a root at 0. I've got a root of positive 4. I know my tails, or end behavior, both up. Well, don't do this yet, but follow along here. What happens if I try to make this work? It's like, uh-oh, I can't cross again because that'd give me another root, and there clearly is not another root, so something's a little bit strange here. Well, this is what the graph looks like. You can verify on your calculator. You're like, well, wait a minute. How come at negative 4 and 4 it crossed straight through, but at 0 it kind of turned around? Well, that's something that's called the multiplicity. If you take a look up here, x to the fourth equals 0. So this root right here has what we call a multiplicity of 4. And in particular, an even multiplicity. So what that means is that particular root is going to bounce because it is an even multiplicity. Usually we see double roots, but in this case it happens to be a multiplicity of 4. Okay, let's check out the next one. So, again, what I like to do, what would you get for that first term? It would be negative x to the fourth. So I know it's a fourth degree. If you multiply this here, your last term is going to be negative 7x cubed. All right, well, let's get our roots. Set each one of those equal to 0. Negative x cubed equals 0. So obviously divide by negative, cube root it, you're going to get 0. So x equals 0 is a root. And then the other one, you set x plus 7 equals 0. You probably do this in your head. X equals negative 7. Now, my degree is a negative fourth degree, so a negative even. Okay, so I know my tails are going to go in the same direction, but because it's negative, both down. Now, we already discussed this. If you know that 0 is a root, you also know that your y-intercept equals 0. So what do we have here? We've got 0 for a root, and then over here somewhere we've got negative 7, and that's a root. Wait a minute, my tails are both down. So again, follow along here. It seems as I could just draw something in like that, and that's close, but it's not exactly right because of that x equals 0. It's not what we call a single root. That's actually a triple root. Or think of it as a multiplicity of 3. Now, what actually happens there for a multiplicity of 3 is we say the graph sort of flattens out, actually changes concavity. So it actually looks like that. So now we've got two different types of multiplicity, an even multiplicity or an odd multiplicity. Okay, so now let's summarize our multiplicity. So I'm going to skip ahead a couple pages. And right here you can see, in general, if the multiplicity of the root is an even number, so double root, fourth root, the function bounces off the x-axis at that root. So think of your parabola, kind of looks like this. That root right there could have a multiplicity of 2, 4, 6, something to that effect. If the multiplicity of the root is an odd number, the function flattens at the x-axis at that root. So if you have, let's say, a triple root here, the function flattens out. So we say the concavity changes. All right, so now what we're going to do in the next day of notes, next lesson, is we are going to graph and put all of this stuff together, including the multiplicity of roots.